morning to the judges and all who is watching this video. Today, we're going to conduct an experiment related to the topic thermochemistry. As we know that we learned about this topic during our Form 5. Okay, we learned about the exothermic reactions, we learned about the endothermic reactions, but we haven't seen results from these two reactions. So, what are we going to do today is, we're going to conduct an endothermic reaction experiment. My teammate here, Daryl, will explain about the endothermic reaction.
Okay, hi everyone. Okay, so we have two types of reactions, namely endothermic and exothermic reactions. As everyone who has read our SPM chemistry books before, you know that the most reactions we study in our syllabus are mostly exothermic reactions. Okay, exothermic reactions, they release heat to the surroundings, but endothermic reactions, on the other hand, they absorb heat from the surroundings and use that heat to supply to the molecules kinetic energy so that they can change to another product, and so they need to absorb heat from the surroundings. However, in most endothermic reactions, you discover that the heat required is not that high. Therefore, the temperature that you will get will not be that low. Okay? But what we have discovered was that NH4Cl, which is ammonium chloride, and barium hydroxide, which is BaOH2, when mixed together, they will participate in a reaction that results in the formation of ammonia gas and barium chloride. Okay, so it will mainly be an aqueous solution containing barium chloride and at the same time ammonia gas will be formed. And what you will see later is that this reaction is an endothermic reaction that will absorb a lot of heat from the surroundings, and what happens is that it will absorb heat from surroundings, so the temperature will be low, and the water that we will drop on this wooden block will totally freeze and become ice. So, behold.
Alright, what I'm going to do now is, I'm going to make these two salts together. Alright, what I got here is, I got a glass rod, I got a thermometer. Now, my friend here, he will actually drop a few drops of water on this wooden block. Then, I'll make these two together and stir it with a glass rod. Then we shall see results, the drop in temperature and how it freeze the ice. Right, let's start.
Okay, a few drops will do.
Alright. Next, we're going to pour this ammonium chloride into this barium hydroxide. For that,
be sure to place the beaker right on the water so that it can be frozen evenly and supercooling can be avoided.
now I'm going to stir it. Oh, it's getting cold right here. Oh, the pungent smell we're now inhaling is actually ammonia gas. Is a very pungent and ammonia gas.
Okay, the gas concentration is getting really high right now. It's really pungent. So be sure to do this outdoors in a condition that's quite roomy, so you won't be actually exposed to this pungent gas for that long. Because ammonium chloride and barium hydroxide, when reacted together, they will result in the formation of water, ammonia gas, and barium chloride. So it's mainly an aqueous solution with barium chloride in it, and that gas will of course be released into the atmosphere.
Alright, you can see on the surface of the beaker, it actually forms an ice plate due to its low temperature. My friend here will continue stirring the beaker, and I'll prepare for the thermometer to take the reading. Okay, right, you can see right here, it actually is covered full with ice. See, this is the result from the endothermic reactions. It absorbs heat from surrounding, thus giving us a very low temperature.
And that low temperature makes it possible for water from room temperature to freeze into ice.
Alright, now I'm going to take the temperature, and I hope it will actually drop a lot. Alright, I'll shake this thermometer for one. Alright, we shall see the drop in temperature. As you can see, it has a rapid drop in temperature. It actually reached a reading of about -0, now is -5 degrees.
Okay, now you can see it.
It's going to reach -10 degrees in about a few seconds. Alright, now it's -5 degrees. Alright, now I'm continuing stirring to ensure that the reactions, the mixture of barium hydroxide and ammonium chloride is complete. Oh, the smell is really awful.
Okay.
Oh, you see, it actually frozen the water below, and this water block sticks with the beaker. Alright, you'll see the power from the endothermic reactions between ammonium chloride and barium hydroxide. It absorbs heat from the surroundings, thus producing a very low temperature at -10 degrees, thus freeze the water below and stick it onto the beaker. That's the results from the endothermic reactions. Right, that's the end for our experiments.
So now let us remove this beaker and see what we can find below it. Okay, if you see closer, you can actually discover that, okay, there's nothing on the wooden block, but the surprise is right under the beaker, is that you will find ice crystals at the bottom of this beaker.
Yes, you will find ice crystals.
That was where it contacted with water just now. You can see that this endothermic reaction has absorbed that much of heat, so that the temperature has dropped to an extent that it is below melting point of water. So it has turned into ice. Okay, so now that the reaction is complete, what we have here is actually a quite concentrated solution containing barium chloride. Okay, so we can use this method to produce barium chloride, which is a common salt that you find in the lab. And I'll give the mic back to you.
Alright, I hope you find this video enjoying, and we'll see you soon. Thank you. The students of Tzun High School.